In this video, we are going to create an expert advisor that utilizes the Relative Strength Index, or RSI, to make trading decisions based on market conditions. Let's see how we can do that. To begin, we start Metaeditor by clicking a little icon or pressing F4. This will open the coding environment where we can write our MQL code. The first part of our code includes the necessary libraries. We use the include directive to bring in the CTrade class from the standard library. This class provides simplified trading methods such as PositionOpen and PositionModify, which we will use to manage our trades. Next, we instantiate a CTrade object named Trade. This object will manage all trading operations, including opening and modifying positions. We then define our strategy configuration parameters. These parameters can be adjusted in the Expert Advisor properties. The Lookback Bars parameter specifies the historical range for highs and lows, allowing us to analyze between 1 and 1,000 candles. The min candles back parameter sets the minimum age for valid highs and lows, which can range from 5 to 50 candles. The trailing offset parameter defines the safety distance for the trailing stop-in points, with a range from 1 to 20. The RSI Period parameter is used for the RSI calculation period, typically set between 8 and 21. The Oversold level and Overbought level parameters define the thresholds for the RSI, indicating potential buy and sell signals, respectively. Finally, the RSI Price parameter specifies the price type used for the RSI calculation, which defaults to the closing price. We then declare some global variables and handles to store state between ticks and indicator data. The RSI handle variable will hold the RSI indicator handle, while RSI buffer is a circular buffer for storing RSI values. The price data array is used to store OHLC price data. The onInit function is executed once when the Expert Advisor starts. In this function, we create the RSI indicator handle using the iRSI function, which takes the current symbol, the H1 timeframe, the RSI period, and the RSI price as parameters. We also configure our arrays as time series, ensuring that the newest data is at index 0. This is done using the arraySetASeries function for both the RSI buffer and price data arrays. Finally, we return the success code in it succeeded to indicate that the initialization was successful. Next, we define functions for opening positions. The open by position function is responsible for executing a buy order. It retrieves the current ask price using the symbol info double function and then calls the position open method from the trade object. The parameters for this method include the symbol, order type, volume, price, stop loss, take profit, and a comment. In this case, we are opening a buy position with a volume of 0.10, which corresponds to 10 microlots at the current ask price, with no stop loss or take profit specified. Similarly, the open sell position function executes a sell order. It retrieves the current bid price and calls the position open method with the appropriate parameters for sell position. Again, we specify a volume of 0.10, which is 10 microlots, at the current bid price, with no stop loss or take profit. The onTick function is the core logic of our strategy and is executed on each tick. In this function, we first retrieve historical price data for analysis by copying H1 candle data for the specified lookback period using the copyRates function. The parameters for this function include the symbol, timeframe, starting position, count of candles to copy, and the target array where the data will be stored. We also load the RSI values from the indicator buffer into the RSI buffer array using the copy buffer function, which takes the indicator handle, buffer number, starting position, count, and target array as parameters. Next, we check the status of open positions. We initialize a Boolean variable as open position to false and set the current position type to position type buy as a default value. We then iterate through all open positions in reverse order to find any relevant positions. For each position, we get the unique ticket number and check if it belongs to the current symbol. If it does, we mark that an open position was found and store its type before exiting the loop. Now we move on to trend detection and position management. If the RSI value is below the oversold level, indicating that the market may be oversold, we check if there are no open positions. If there are none, we call the open by position function to open a new buy position. If there is already a buy position open, we identify the lowest low in the lookback period using the ILowest function. We then check if this low point is at least min candles back old and if the current price is above the identified low. If both conditions are met, we calculate the new trailing stop level by adding the trailing offset to the last low price and call the process trailing stop function to manage the trailing stop. Conversely, if the RSI value is above the overbought level, indicating that the market may be overbought, we follow a similar process for sell positions. If there are no open positions, we call the open sell position function to open a new sell position. If there is already a sell position open, we identify the highest high in the lookback period using the IHighest function. We then check if this high point is at least min candles back old and if the current price is below the identified high. If both conditions are satisfied, we calculate the new trailing stop level by subtracting the trailing offset from the last high price and call the process trailing stop function. The process trailing stop function is responsible for managing the trailing stop for both buy and sell positions. It loops through all open positions in reverse order and selects each position by its ticket number. We check if the position matches the specified position type and belongs to the current chart symbol. If it does, we retrieve the current stop loss value. For buy positions, we update the stop loss if the new level is higher than the current stop or if there is no existing stop loss. For sell positions, we update the stop loss if the new level is lower than the current stop or if there is no existing stop loss. Finally, we press F7 to compile the code. If this was too fast for you or if you don't understand what all the code is doing, you may want to check out the premium course on our website or watch one of the basic videos first. If everything works correctly, we go back to Metaeditor by pressing F4 or clicking on the icon. Back in Metaeditor, we press Ctrl and Alt to start the strategy tester. We select the expert advisor that we have just created, enable the visual mode, and start a strategy test. We should see the expert advisor operating on the chart. If you are already a premium course member and have an idea for a video like this one, feel free to send us an email. In summary, we have learned how to code an expert advisor that utilizes the RSI indicator to make trading decisions based on market conditions. We have implemented a few lines of MQL code to create this functionality. Thank you for watching, and I will see you in the next video.